session today. My name is Evan. I'm with Armory. I'm here to introduce today Chuck. He's with Salesforce, and he's going to be talking about debugging and profiling Spinnaker applications live. Please give me your attention in a hand, and we'll have some time for questions afterwards. Thank you.
Hi, everybody. When I went through the draft on this, I got about 5 slides in before someone in the audience asked me if I was presenting. So hopefully it won't be quite that bad today. And I could see it. So, well, first I want to welcome you all. Thank you for coming to the talk. Just a little bit about who I am. My name is Chuck Lane. I am a lead member of our Spinnaker service team. And my talk today is about how to debug and profile Spinnaker microservices live inside of a Kubernetes cluster. So a few of the things I'm going to be covering today are basically how to get started if you want to go in and actually debug a Spinnaker service, in particular Cloud Driver, for this talk. So we're going to talk about how to use the BOM and figure out exactly what version of Spinnaker image you're running, how to configure halyard or inside the Kubernetes cluster so that you can enable debugging inside the service itself, configuring IntelliJ in a way that will let you connect the debugger to the actual service, and then where to set the breakpoints. The second portion of the talk is going to be about using an open source tool called GlowRoot. It's a JVM-based profiling library, and in order to use this, you're going to need to build a custom image of, in this case, Cloud Driver, with the GlowRoot binary, and then basically deploy it into your cluster and connect to it. So. For this slide, I'm going to talk a little bit about why you would do this kind of debugging. So, from time to time when you're running Spinnaker production, you might come across errors in the log that you only really reach in scale. In our case, as we ramped up the number of Kubernetes clusters that we attached to our Spinnaker instances, we started to come across errors from time to time, and when we would try to reproduce them in dev environments, they just wouldn't happen. One issue in particular was related to the credentials call, so that's one that I'm going to be demoing for you. As we scaled it up, it got to be really, really slow. It went from 3 to 6 seconds, maybe all the way up to a minute and a half, or it would just time out. So, this is kind of what took me down this road of figuring out how to hop in the debugger and figure out what was going on. I was just kind of trying to get some answers to those questions. So, before we tried debugging, we did try a number of approaches to tweak Cloud Driver. We tweaked configuration settings, we scaled the pods, we tuned our JVM options. I read through many Spinnaker GitHub issues and talked to Eric and a lot of other members of the community. And we built tools to kind of get an idea of what was going on, track our metrics, see how quickly things were responding, and went from there. But none of it worked. So at the end, what we ended up doing is figuring out how we could build our own images and kind of get this done. So how are you going to do this? The first thing you're going to need to do is you're going to need to clone your Cloud Driver code down to your system. Once you do that, then you're going to need to know how to get to the actual commit for the image of Cloud Driver that you're using. So I'm going to go ahead and demonstrate this live just because I'm actually more comfortable doing that than talking through slides. So basically here I've got the Cloud Driver source code, and let's see. So for example, if we wanted to connect the debugger to this particular instance, in our case, well, we use halyard to deploy it in a lot of ways, and so deploy Spinnaker. So to get the actual commit that you're going to be using for a particular image, what you're going to do is jump into your halyard pod, and there's a great command. I was looking for. Hal version bomb. And so basically with this, it's going to give you an idea of what version you're actually deploying out to your, well, Kubernetes cluster where you're running Spinnaker. And then it's going to give you a list of each of the commits and the associated images, which will help you navigate your copy of the code to the actual code that will align with the image you're trying to debug. So in this case, we're interested in CloudDriver, and the commit in question is this long hash code here. So we'll go back to where we have the source code, and we'll pretend this was on master. What did I do? And check out the commit we're interested in. So now that we've cloned the source code and we've figured out how to get to the particular commit, the next step is to configure IntelliJ in a way where we're going to be able to debug into it. So here I've got a copy of IntelliJ. Open it up, and in my case, I already have the CloudDriver code loaded. If that's not something you've done before, there are some gotchas to get there, but it's certainly doable for anybody who wants to learn how to do it. At this point, what we need to do is go in and actually define a profile that will allow us to run the debug inside of IntelliJ. So to do that, you can go up here to run, and you can edit your run configurations. And then there's a great template right here for remote. And in this case, what you need to know is you need to know what ports the debugger run on the Spinnaker service that you want to debug. So for that info, Spinnaker is nice enough to put together a web page. Hey, look, it's Ethan. And here down at the bottom, there are basic instructions on more or less how to do what I'm talking in the first part of this talk about. And then there's a list of each of the services and the associated port that you're going to want to connect the debugger to debug this. In general, it's 100 more than whatever the port is that the service runs on. So like CloudDriver by default will run on 7002, debug it on 7102, front 50, 8080, 8180. So they all follow that pattern. So the next thing that we need to do is actually go and update our command line argument with the appropriate port, and then we need to make sense of these commands and kind of what they do. So as far as, the first part of this just basically tells us how you're going to talk to the service, in this case over a socket, so that's relatively self-explanatory. It does run a server that's going to allow you to connect, and then this suspend no or yes is somewhat important. So if you need to start up the service and you need to debug any part of the startup, then you're going to want to set suspend to yes, because basically what it does then is it will not start the service until you connect the debugger to it. This can come in handy if you are trying to debug startup issues. Don't really want to set complex breakpoints, whatever. But for the purposes of this, I'm just going to stick with a simple example. Choose no for suspend. And copy this. So now that we have the basic command line arguments that we're going to need to pass to the JVM, we need to figure out a way to launch the Spinnaker services with those arguments. There are a couple different options for doing this. So for the purposes of this one, I'm going to show how to do it via halyard for those of you that use that. So basically you're going to need to jump into whatever pod you use for halyard or however you run it. And then go into your service settings. And then if there's not already, you can create a cloud-driver.yml. In here you've got your Java options, which are part of the environment variables that you can pass in when it starts the service. And you can pretty easily just add it here and go ahead and save your file. Once you've done that, you can use halyard to redeploy the service that you've updated. So there are some trade-offs for this. If you wanted to make changes long-term, if you were setting up a dev instance where you always wanted to be able to debug, then you would probably want to do something like this in halyard. If you were trying to debug something in production, you wanted to be short-term, then you would probably just edit the deployment directly. So I'll go over that in the next half. So after you've done this, you're going to need to wait for the Cloud Driver pod to come up and be available. And we can all thank Eric for this because it's faster now. Supposedly.
Well, aren't you on 14.9? Is that right?
No, this is newer.
How did there
I saw 16 feet.
4 containers in your pod?
So one of them's the monitoring daemon, and the other is proxy stuff related. So, not out of scope. So if you're curious and you want to see just to make sure that your settings have actually gotten in there, of course, you can always go in here and actually take a look at the YAML for the pod itself. And if you get on here to your JVM options, you can see here where the debugging JVM option has been added to this pod's deployment, meaning that when it comes up and it's available, we'll be able to connect the debugger to it. So while we're waiting, I'll talk a little bit about Claw driver code and how to kind of figure out where you're going to be hitting the debugger, or where you're going to be setting the debugger. So I mentioned the credentials call a little bit earlier, and basically what that is a call that Claw driver uses to have a list of, where it gets a list of accounts, and it's used all over the Spinnaker ecosystem. Basically, anytime one of the microservices is curious about what accounts are available and what it might execute on, it hits the credentials endpoint in Claw driver to get a list of what the account names are, what provider they're using, and just some other general information. So Claw driver, like a lot of the services, is laid out in such a way where there's a -web folder, and inside of that is, if you drill down into the Java source code, it's an MVC pattern, right? So you've got your applications controller, your cache controller, and then here, the one I'm interested in, your credentials controller. So once you open up the credentials controller, you can look for something that has a request method of get and a method declaration that's just a list. In this case here at the top, this is the one that just gets hit when the Claw driver / credentials call gets made. And we're up. All right, so one final thing that we need to do before we're ready to attach is to actually forward the port from our local machine to the Kubernetes pod that's running in the cluster. So to do this, we'll make use of the built-in kubectl port forward command. And in this case, I'm actually going to forward 2 ports, so I'm going to run it twice. I'm going to port forward 7102 to handle the debugging traffic. And then I'm going to port forward 7002 so that I have an easy way to hit this pod directly. Where did my magnet go? Oh well. All right. So if we check, we'll be able to see that both of those are running. And now we need to go in and we'll actually be able to connect the debugger. So to do this, basically go to run and then debug, and you can choose the unnamed configuration that I showed you how to define earlier. So you'll see here that we've connected to the target instance, and I'm already getting hit on old breakpoints. So if we go down here, we can curl localhost credentials. Not sure whether that was mine or not. Yeah, that was too fast. And here you can see we've hit the breakpoint inside the code, and we have all the functionality that you would expect if you were debugging the code locally. So you've got your ability to look at your local variables. You can step into particular methods and do anything that you may need to do to explore why a particular error is occurring. And IntelliJ's got a pretty robust system around if you want to set conditional breakpoints, or if you it's come in handy a couple times if you're having a particular exception and you're not sure exactly where it comes from. Of course, you can go in here and make the debugger break for a particular exception, just like you would if you were running it locally. So so you can use this to basically determine kind of where your bottlenecks are and adjust your configuration appropriately, and then rinse and repeat, and that's more or less the ins and outs of how you get debugger connected to Spinnaker while it's running. Are there any questions about that particular part before I move on to profiling?
That's really cool.
It's really cool.
All right. And I don't think I needed too many of these slides because I didn't lose connectivity, so we're good there. All right, so now on to profiling with GlowRoot in this case. Like I said, GlowRoot is another open source JVM profiling tool, and basically what you're going to do is somewhat the same process. The big difference here being that you're actually going to need to build a custom image that has the GlowRoot binaries in it. So in this case, I've gone ahead and downloaded the binaries already. So they are here, the GlowRoot jar and the GlowRoot lib. I just downloaded them directly from the website and copied them to a place next to the CloudDriver source code where it kind of made sense. So the next thing you're going to need to do is actually build and compile CloudDriver. To do that, it's a two-step process with the newer versions of CloudDriver. Basically, you build the first layer with the compile tag, and it kind of puts everything into there. And then you're going to build the second layer with your own custom Docker file where you've added in the GlowRoot binary. So for the purpose of this demonstration, like out of the box, when you just clone the repo, you've got the Dockerfile compile, the slim, and Ubuntu. All I did was copied over Dockerfile slim to Dockerfile GlowRoot, and then it was relatively easy to go down here and add in these three lines. So this line here copies the GlowRoot jar itself to a particular location in the container. This copies the lib, and then finally I made the permissions relatively permissive for the purpose of this, just for ease, the sake of ease. So after you do this, and you've created your Docker file, then you can go in and build Spinnaker, the CloudDriver, the same way you normally would. So, in this case, it's usually Docker build -t -f Dockerfile GlowRoot, and call it this takes a while. So I'm not going to make you guys sit through this. But alternatively, if you wanted to be real lazy about it, I guess you could just reference the GCR image that was out there and probably add those commands into the end of it and build your own that way, and that might work as well. But like I said, basically the couple of lines you need to add are here, and then as you're going through your Docker build, you'll want to look for that it's actually been updated and that it's building the new image with the glow root binaries. So the next thing that you need to do is set the service settings for glow root. In this case, I'm going to demonstrate basically how that would look inside of the deployment itself instead of doing it via halyard. So for this, what you can do is kubectl edit Spinnaker deploy spin cloud driver. And here you'll have your cloud driver deployment. And in this case, it's going to be the same one where we just did the debugger, so we'll just remove that. And here we'll add in the JVM options for the Java agent option, basically that tells it where the actual glow root binary is at. In addition to this, the other thing you're going to need to do is swap out the image reference and point it to the image that you've built that actually has the binary in it. And then you can just update this in place. And you'll see that the new cloud driver pod is already up and running. So in this case, we don't actually have to wait for it to come up and be healthy, I don't think, before we can connect to the Glower UI. Although there won't be a lot of traffic until it does. But anyways, the big difference here is that the port's different. So we're going to use basically the same process of kubectl port forwarding. Oh, forgot the pod name. And in the case of glow root, the port you need to forward by default is port 4000, which I'm sure is configurable if you really needed it to be. And so here you can see we've forwarded port 4000 and we have access into a basic profiling tool that's now running on our cloud driver pod. as this spins up and starts to receive some traffic, you can see some of the endpoints that are being hit, the health check endpoint, metrics endpoints, credentials. So from inside the profiler, you can look at a number of different pieces of information about the cloud driver as it's running. Slow traces, and information about the startup. Based on this, depending on what the issue is that you're trying to solve and kind of what your use case is, then you can tailor requests into it to put some load on the endpoints that you're interested in, and even take a look at errors that may pop up depending on what those are. So from here you can take a look at a stack trace for an NPE that's thrown, or whatever it is that you're interested in as it relates to profiling. There's also some information in here about the JVM. So if there are questions about how Cloud Driver uses the JVM in a particular way, we've got some gauges here where you can get information about that. And then ultimately, if you wanted to run this on a larger scale regularly, there's reporting and stuff that's built into the profiling tool, like you would expect. So yeah, so that's basically what I have for profiling and debugging. Are there any questions from anybody or specific use cases, things I might be able to answer? All right. Well, thank you very much.